Can you repeat that, Lydia?
Yes, I couldn't find any charts for the F distribution. Remember, we had the normal distribution
and they
chart.
said that they just give it to you in SPSS. They give you the p-value.
Yeah, but okay. So that's what
that's what I was wondering the same thing you were. I was like, wait, they haven't given us a normal chart, but they just give you the information in SPSS.
So you can't really like graph it?
Calculate it?
Yeah.
You can't really graph it, no.
Well,
What was it called, Katie?
It says SIG, yeah, it's just SIG period.
Okay.
I can't like look at it to verify because I don't have it open. I'm trying to open it.
Yeah, I have like a screenshot of one from the quiz.
Okay.
I can show you. It was when it was 0, but when the p-value was 0. But I can show you. I'll share my screen with you and see if you can see it.
So yeah, it froze up. I know. It's like, why did you send it back?
Okay, can you guys see this? See right here where it says SIG?
You send me a new laptop.
Yeah.
That's
Keep
the
talking.
p-value. I'm going to keep talking. The SIG is right here. So in this case, the p-value was 0, but yeah, that's where the p-value is.
Got it.
Yeah, it looks different on the one for this week, but
Yeah, I was just taking it from.
it's kind of similar to that.
Let me stop screen sharing. Okay, perfect.
All right, so we can all start the quiz now?
Yeah,
Yeah.
sounds good.
Sweet. Lesson 14, right?
Yeah.
That wouldn't be entertaining is the fine afterwards throwing the laptop.
Alrighty.
It feels it's so crazy that the exam
18
is.
questions.
I
Well,
wouldn't even mind that after this laptop.
And we will need the normal probability output and soccer shoes and DASL hot dog and nutrition. So we might as well pull up our SPSSs now.
Yeah, I'm gonna try that. It'll take me a while.
Soccer shoes and DAL.
Taylor's not married.
DASL hot dog nutrition. Okay.
Oh, that's so true. That's true. Yeah. I've been married for 4 months, so.
You guys have only been married for
I'm
4
gonna have
months?
an anniversary.
Yeah.
6 months we might celebrate something.
I didn't know that.
Yeah, we're newbies.
That's so fun. How's it going?
It's pretty good. I love it.
Lydia, how long have you guys been married? You have like a family and stuff.
15 years.
Oh
Yeah,
my gosh, that's crazy.
it's a long time.
Okay, so questions 1 and 2 we got. Question 3. It says, in an ANOVA hypothesis test, we reject the null hypothesis when there is sufficient evidence to indicate at least one mean is different from the others.
True.
Yeah, I think it's true.
True. Yep. So I will
Oh
start
my
using.
gosh, my computer's stuck.
Well, it's still fun. Hopefully we can.
Okay, let me know if you want me to
It's
wait.
really fun for,
Okay, it's just trying to open up both SPSS things at the same time, so it like froze
Yep.
up my whole computer.
Mine is too.
you know,
Oh, maybe mine did too.
Mine's just loading.
we had to start working.
Takes a while. That's why I just do one at a time. And then when we use the second one, I'll pull up the second one because
Yeah.
it's not worth it to have it load forever.
Yeah. Let's see.
My wife, that is weird.
Okay, there we go. I think I got it to work.
She told me that's funny.
Okay, so we decided true on number 3, right?
Yes.
Okay. Number 4. What requirements need to be checked when performing an ANOVA hypothesis test? Mark all that apply. I think it's the last 2. Data in each group are normally distributed, so we do the QQ plot for all of them.
Yeah.
And the variants are equal, which
Yeah,
equal
let's
means
just admit it, there's not
4
many
times
models.
each other, whatever.
Yeah, I think so too. B and C.
I don't know about the sample means are all positive thing.
Should we? You don't know if that's for sure false.
I don't think that's one. I think it's just bottom two, but I might be wrong.
Pretty
Let's
much.
see.
It's,
So we're just doing B and C, right?
B and C, yeah.
Yeah.
I think so.
I've looked up in the school system. how many-
ANOVA is a test for equality of several means.
Me, my wife,
Um,
my brother.
some means are positive. Okay. It allows us to compare the means for several groups in one hypothesis test. It might sound intimidating, but ANOVA is simply a way to analyze several means
My
at
sister
once.
used to be on there as a allower, but she's
Um,
married, so.
It is based on a comparison of the spread of the data within each of the groups compared to the spread of the means of the groups. In a ANOVA test, the
No, she's
hypothesis
still
is
unique.
typically
There's only
expressed
her
in words,
and her sister.
and an alternative hypothesis is given. If the means differ from each other, then we conclude the means are not all equal.
Sorry, I'm
If the means do not differ, then we do not reject the hypothesis that the means are equal. We will use a level of significance A and the p-value just as we have with our other hypothesis tests. So let me just scan through and see if it says if they're all positive. The values of F are never negative.
But it doesn't
So-
say anything about the means,
It
though.
doesn't say about the
Oh,
mean,
right,
yeah.
right.
They want to trick us. In this.
Yep.
Okay, perfect. Let's stick with B and C then, if you guys are good on that. Okay,
Okay.
awesome. Lydia, do you want to read question 5?
Yes. To check if each group is normally distributed, do the following. So you do a QQ plot, right?
Mm-hmm.
Yes.
For each group.
Yeah.
Construct a
I think
QQ.
I'll just stick with the
So
state.
C.
Yes, so it's C.
I wish I could afford that. I still can't afford it. The only reason why I ever get steak is if I go home, and that's because my parents have, like, they own cows and kill them, so.
Okay, Katie, do you want to read question 6?
Yeah.
Okay.
Okay. We assume the variance in each group is the same if the following happens. Sample variance for each group is smaller than the sample mean. The largest variance is less than 4 times the smallest variance. The largest sample mean is less than 2 times
Yeah.
the smallest
No,
sample
most of the time
mean,
we
and
just
each
go to
group
all
has
part.
the same sample size.
B.
So B, right? Yep.
Okay, so is
Yeah.
everybody in the test? Did anybody have any questions on the homework assignment? Or on the preparation assignment? I thought it was pretty straightforward. But
I can read the next one.
Okay.
An ANOVA hypothesis test is equivalent to conducting independent two-sample t-tests between every pair of samples. If there are 3 samples, there are 3 pairs. 1, 2, 1, 3, 2, 3. How many pairs are there when there are 4 samples? To be 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, 3, 4. 6?
That's what I'm thinking.
Is that a thing?
Yeah,
I don't know. If you don't repeat combining them together. I
right.
think it's 6.
Yeah, I think that's right.
Okay, 6.
Cool. That one was pretty easy.
Yeah.
Soccer shoes. All right, let's calculate. So we need to do automatic recode, right?
Is this the same as the preparation assignment? Looks like.
The shoes? It's not. I don't think it's the same.
Or was it the homework? I think it was the homework.
Do not know, but
So we're recoding the accuracy?
no. Wait, are we recoding? I thought we do the footwear because there's A and B.
Is
in
it
footwear?
footwear?
Yeah.
Oh, okay.
I think so.
I just always get confused which one I'm supposed to put in there.
Me too. And then we analyze, compare means, ANOVA, kicking accuracy, and the factor is new, right? Maybe.
I think so. Yeah.
Woot.
Okay, so do you see on the right side where it says SIG?
What did you guys put?
Does
for
it say
the-
0.081?
Uh-huh. That's your
Got it.
p-value.
P-value.
I know that's not what
That's
it's
very
asking for, but I'm just showing you.
That's very helpful to know where it is. So what is the minimum smallest variance for the 6 groups? So that's sum of squares. That's not, is that the standard deviation? We need to find the standard deviation, right? Where is the standard deviation? Oops. My computer's freaking out. Come on. It didn't give me the standard deviation. Do we need to explore for that?
Yeah.
Oh yeah, I think so.
Analyze, dang it. Okay, I'll
So
do
what
that.
did you put, what did you, I'm lost today, for the automatic recode on the variable box, did you put footwear?
I put the new footwear, yeah. Wait, for the recode, you put in footwear and you type in whatever thing you want to call it, and then you can do it
It's not
again.
letting me now for some reason. Let's see.
Oh, no.
Oh, there
And
it
then
is.
if you're exploring, I can't remember. I'm going to go look at the book to figure out for explore because I don't remember what you do for explore. You need to summary statistics, compare means, explore. Automatic repo code, one-way ANOVA. No. I don't remember how to explore for some reason. Where is it? There it
Explore
is. Descriptive,
is,
explore, dependent box, and factor box.
yes.
So move the variable containing your data in the dependent one. Okay, that's what I was wondering. I was like,
So
which one
dependent is kicking, right?
Yeah, kicking, and then you put the new one in
the
your factor list, and then you push OK.
Okay.
And actually, if you go to options, it will show you QQ plots if you need them, but I don't think we need them, so we're good. Actually, we might need them. I don't know. We'll see if it asks for it.
Holy cow, that's a lot of stuff.
Whoa. Where's what we need?
Let's see.
So minimum variance for this.
Minimum variance for.
6 groups.
Do we find that in the box? The descriptive statistics?
Well, it gives us a minimum and a maximum, but it's under each group. So would it
I
be
see. No, you find the for
under
variance.
socks?
Yeah, so let's write them down. So we have for A, it is 27.358. B is what? 484.
Mm-hmm.
C is 208. Then D is 53.158. E is 40.724. So the smallest one is the 27.208, which is C. So there is C. I think 27.208.
Yeah, that's the one. Yeah.
27.208 is what we're putting.
Yeah.
Okay.
Yes, exactly. Then the maximum is D, which is 53.158.
Yep.
And then they want us to check the variances. Calc. So 27.208 times 4 is bigger. So we're good. So the test.
So 10 is true.
Yeah.
Yep. Sweet. Then 11, we got to construct the QQs. Dang it.
For each sample. Yeah, we do have to do that. Okay.
Dang it. Go back to Explore. We should. Actually, we could do graphs. No, just go to Explore and make them. It's really easier. It's a lot easier.
You just
So I can get to
go.
it. To the options. Options. Oops. I want plots. QQ, unleaf, histogram. Where is it?
Yeah, QQ.
Mostly plots.
Isn't QQ?
It says normality plots. Do you see it?
Yeah. You
That's
click
what
on the
it is.
box.
What if you were
Yeah.
to go to analyze descriptive statistics and then QQ plots?
It might not have the A, B, C, D options. It might just have all of the things together, and we want them separately. So it might be easier just to go to analyze.
So you did analyze descriptive statistics, or no?
Analyze, go to plots. Did before we go analyze, which is descriptive statistics, and explore. And then we put in whatever information we need to, and then when you click on plots, and it says the normality plots or whatever, and you click on that box to check it, and then it'll bring up a whole bunch of plots when you're good.
Okay.
And it looks like A is good, B is good, C is good, D is good, E is good.
Yeah, they all look good, right?
What does
Yeah, they look good to me.
detrended mean? I have like two sets.
Detrended?
Yeah.
Yeah, detrended just means when you change the x-axis, I think.
Oh, okay.
I don't know.
Yeah, but they said not to look at that one.
They said not to.
Yeah,
Okay.
don't worry about don't worry about that.
one.
And they're all good, right? So true.
Yeah.
Yeah.
Sweet. Perform an ANOVA test in SPSS and observe the p-value. Oh, yes. Then remove the SOX data and perform the test again. What?
How do you do that?
Yeah.
Remove the data.
Erase it? Erase it from the database? Or not the database, the spreadsheet? Let's see.
Let's erase the data and do it again.
I would just copy it in case we need it.
Do they mean to like exit out of your outlook?
No, erase the 101
Do it
through
again?
120. I think what they mean is erase from 101 to 120, which is
Oh,
the SOX.
I feel like there's a way we should be able to select it. I'm just not sure how.
Oh. Just, it's not like we need to save this chart for anything. Set it up and skip this one and move ahead. Whatever you guys want to do. Because I don't know what it means, but we can think about it for a while. Or we
Yeah,
can
'cause-
finish everything and then come back. Or we can go up to the point of the
Oh,
next
okay.
SPSS thing and then come back and then do the next one.
Sure. Okay.
Until let's just do number 13 and then we'll be good. Actually, we might need to
Okay.
do 12 to
Yeah.
13 though.
Yeah.
The test statistic for an ANOVA hypothesis test is an F statistic. Is the p-value the area to the right or the left of the F statistic?
To the right. Yeah.
Right.
Yeah, because it can never be
Right?
negative.
Right.
Yeah.
Okay, cool. So now let's go back to 12. Then remove the SOX data. So let's look at the data plot.
So there will be 5 groups.
Well, there's footwear and there's A, B, C, D, E, right? What's the difference between them?
Yeah.
Oh.
Just,
So, do we just delete it?
There's probably an easier way. I just don't know what it is. There's probably an easier way than deleting it, but
Yeah.
I don't know.
remember if it was in
Did
the
it even
video.
calculate for SOX last time? What letter was it representing? Calculating for SOX.
I got
Maybe-
0.309.
After you deleted it all.
I don't know if I did it right though. So maybe we should see if someone else gets that.
Let me see.
Oh, I see.
yeah, 0.309.
Yeah, that's what I got.
Yeah, I think.
Did
I
anybody?
didn't calculate the variance for socks, but thanks goodness it wasn't that big of a deal. We're good. I didn't know what I was doing. Okay, so if you take these and go and delete them, delete. Cool.
I'm trying to find out if there is.
So then you guys
Another
did
way,
the
like-
whole descriptive statistics again?
I just did the ANOVA test one.
Yeah.
Oh, a NOVA test. Okay, that's
Yeah.
probably easier. Oh, cancel. A NOVA test. 1 second. Let me see if we all got the same thing. You guys all got the same already?
They both did. I'm trying to see. I'm looking at the.
Oh, I got 0.309.
That's what you guys
Yeah.
all got. I think there's an easier way to do it, but let's go with that. If we get it wrong, then we'll delve deeper. and
Then
see
we'll
if
try
that's-
to, yeah.
Yeah.
Okay.
I guess it makes sense, but I don't know what else they want.
But I just wonder, like, if we had
All
a
right.
really, if we had a really big, lengthy report, and they said to do it, there's probably an easier way to do it. Yeah.
Yeah.
But that works for B. Let's do 12 is 0.309.
Okay. Next one is beef and meat and such. So we need a automatic recode. Are we doing calories? Do we know if we're doing calories or sodium?
Let's examine the calories first, it says.
Oops.
Okay. So we do the type in there and make it new. Add new name. Okay. And then we're going to.
So what are you doing? Calories first?
Yeah, that's what it says.
That's what the first question will ask for. So we shall try that.
Do the ANOVA test, we're putting,
So we're putting dependent is calories. Then the factor is the new
the new
thing.
one. Okay.
Yes. I don't know what you guys type in. I just type in new. So
I type in code.
Yeah, I typed in
Calories code.
Yeah, because they told us to.
yeah, I just do new because code. I'm like, wait, what's code again? I don't remember. Explore. Dependent is calories. And then factor list is the new. Then plots. Normal. Continue. Okay. All right, what's the first question I asked? Let's examine the calories first. Construct QQ plots for each. So describe the QQ plots and the variances.
So just go to explore. Calories.
Yeah, I'm going to look at the QQ plots first. And I shall erase my board. Again.
I think they look normal-ish, except that last one looks a little funny, but I think it's still normal.
Beef is QQ normal. So there's beef and poultry. What's the other one? Meat. Meat was normal.
types.
Was there only 3 of them? Or am I missing one?
There's just 3 of them.
Yeah.
Okay, cool. All right, and then for variances, we shall write it over here. We're in the Explorer. Stop moving. There we go. Variance for beef, 512.661. Meat is, oops. comes up 636.846. Then poultry. Oops, let's swap those. Oh, stop moving. 50866. Okay, so the highest is 636, and the lowest is 508. 508 times 4 is definitely bigger than 636. So the assumptions have been met. It is safe to assume that each comes from a normally distributed, and we can also assume the variances are equal. So A looks correct. The assumptions have not been met. That doesn't look right. The assumptions have not been met. That doesn't look right. The assumptions have not been met.
Okay.
So, right?
Yeah, I think so.
Okay. So, because I think it's all right. It looks right to me. Maybe how perfect does a QQ plot have to be?
Yeah.
Right.
They look good to me.
I know. I'm always like, oh no, that's so spread out, and then they're like, nope, normal. I'm like, oh, all right.
Yeah.
I think they're pretty
Okay,
lax
good.
on normal, as long as it's not totally like all over the board.
Yeah.
Yeah.
How about 15?
I don't know what takes between.
So for 14A,
A?
okay,
Because that's the only one that's everything's fine. So.
everything is safe to assume. Okay.
What happened to? Oh, there we go. Okay. 15. Run an ANOVA test. Determine if the mean number of calories is the same for all 3 types of hot dogs. Are they? I don't remember. The mean is 11876. Mean is 15871, and 15685.
Okay. It says you should find that the degrees
It
of
is.
freedom are 2 and 51, that F
Mhm.
equals 16.074, and that P is 0, with a level of significance equal to 0.05.
What conclusion can you draw? So does the book talk about interpreting this information? Let's go look. La, 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 la.
But yeah, they did.
I don't remember.
They did the soccer shoes example in the book.
Oh, that's where
They
they
did?
Well, yeah.
They did part of it. They mentioned it, but I don't think they did the whole thing.
No. But I think that's what Lydia was talking about.
Oh, okay.
Yeah, I think so.
Yeah.
I don't see anything about it giving. Oh, maybe it's at the very top. Maybe it's at the very top. And it's like, oh, this is what you get. Haha. So, F distribution, requirements, how to conduct, example. I don't see it. Wait.
Are we supposed to compare the variance then? Because like in this one section it says if the largest variance is at least 4 times as big as the smallest, we'll conclude population variances are not equal.
It just wants to know if the mean is the same. So does that mean we run the ANOVA test and see if the p-value is lower or higher? Yes, as in like you reject the null? Is that what they kind of mean?
Well, yeah,
So
I
if
wonder because they
p-value is
say
0,
the level of significance. Yeah.
so if p-value is 0, that means it's enough to reject the null. Right?
Yeah.
Yes, yeah, that makes sense.
Okay.
Yeah.
So if we can reject the null, then we do not have sufficient evidence. Nope. We have sufficient evidence.
We do have, yeah.
Yeah.
We have sufficient evidence that all hot dogs types have different mean number of calories.
D
We have
sounds,
sufficient. How about D? It sounds more correct.
yeah.
Okay.
I think it's either C or D, but D looks more correct. I think.
That's what I'm thinking.
We have sufficient evidence to claim that at least one of the hot dog types has a different mean number of calories than another type.
Yeah, because if the p-value is different, that means at least one. Might be all of them, might just be one. We don't know.
Yeah. Mm-hmm.
Right.
Let's go with D.
Sweet.
Okay.
Now we're doing sodium levels, so let's.
Should I read?
Sure.
Now let's examine the sodium levels. Construct QQ plots of the sodium level for each of the 3 types of hot dogs. You should see that the QQ plot for poultry suggests a possible problem with the normality assumption. The smallest variance is 7180.75 and the largest is 1092.8.
Oh, we could have done both of them at the same time. Just realized
The
this.
assumption
Yeah. Oh well. So just sodium on the variable box and then sodium code or whatever new name, right?
Yes.
Hmm.
Well, I'm gonna do the new ANOVA and Explore with these. So
But are you gonna recode it or no?
I don't think you need to because you already recoded it.
The calories, right?
We recoded it for both because we weren't recoding calories. We were recoding the
The different types.
different types.
The different types. Okay, yeah, that's true.
I was like, gone from my mind. All right, for sodium. Gotta rewrite things down, don't I? So, we got beef, we got meat, and we got poultry. Beef is 1049.87. For meat,
Calories.
oh, thank you. Okay, the meat is 8812.015, and poultry is 71850. Oh wow, we might actually have a non-variance equality thing. Okay, then the QQ plots. Meat for beef looks normal. The second one for meat looks. Third one looks normal. But the variances looks kind of sketch. Maybe not. The 1, 2, 3, 4, 5. 1, 2, 3, 4. So 7180.75 times 4. So never mind, they are equal. So have been met. Right? Possibly?
Say that again.
I think that the assumptions have been met, but
So yeah, I think it's
I think so, yeah. So would it be A then?
I think so.
Okay.
Because everything else says they have not been
Right,
met.
that's true.
So despite the possible problem with the QQ plot, guess I should go back and look at my QQ plots. Poultry looks fine. What's it talking about?
the possible problem.
Seriously? It says there's a possible problem.
Yeah.
Is it because it
I don't
goes
see-
a little bit lower than it should underneath or something?
Well, it's the lowest one. It's the smallest one, but it's not much lower than meat. Well, maybe it is. I don't know. It seems fine to me. Possible problem with QQ plot for poultry. You decide to use the ANOVA to determine if the... Oh, so it's assuming. It's like, what if you think there's a problem? Use the ANOVA to make sure there's not a problem. Okay. And it says, are the sodium levels the same? So what's the p-value? So we're asking, oh, do we reject this? That's basically what it's asking. It just had a little funkiness in the beginning.
So for question 18,
Going back to the ANOVA
question 18 is
test.
asking if we reject it, so we just need to find out p-value.
Yeah, it says 0.179. So that looks
Yeah,
bigger.
that's what I got.
Yep.
So we
That's right.
fail to reject. So 0.179, everybody, right?
Yep.
Mm-hmm.
Sweet.
Yep, that's what I got.
And then we have one more question.
And because it's
Yay.
bigger,
So what did you
We
decide on
want to-
16?
point, oh,
0.1, oh wait,
A.
A.
A. Okay.
It's not A. We do not have, maybe B. We do not have sufficient evidence to reject. Wait,
We
Yeah.
do not. It's B.
wait. Yeah, because we are not rejecting. Wait, we're rejecting.
We do
Wait,
not
no.
have.
We failed to reject.
We're failing to reject.
Okay. So we do not have efficient evidence to reject it. So B.
Yes.
Whew. My brain's already going.
You did great. I feel like you carried us.
All right, let's turn it in.
Okay. Yay!
Really? First try, guys.
You guys are so good.
Sweet.
High five.
Woo! Okay. Awesome. Well, let's reconvene on Thursday at 7.
Sweet.
Alrighty.
Okay.
So we're taking
All
it's the
right.
test review, so bring notes.
Seriously. Ugh. I can't believe it's already. I feel like we just took a test.
I
Yeah,
know.
me too. I'm not
I'm pretty sure we
excited.
did.
Yeah.